Section 8.1, comparing and interpreting rates. So first of all, a definition of a rate. A rate is a comparison of two amounts that are measured in different units. For example, keying 240 words in 8 minutes. And so you'll be used to rates in the grocery store. It could be like $3 a kilogram for a fruit or vegetable. You might also be used to this in gas, liters, or sorry, so many kilometers per liter or liters per kilometer, something like that. Okay, so rates are all around it, but what we're going to do now is we're going to compare and interpret rates. So starting with this example, a triathlon consists of 3 different races: a 1.5-kilometer swim, a 40-kilometer bike ride, and a 10-kilometer run. Just a side note, Miss Canton has completed a triathlon. It was much shorter than this, but I've completed one. Okay, so the time it takes to transition is given next to it as transition. So that means to go from swimming to biking, you're going to be in your bathing suit. You're going to have to quickly put on some clothes and a bike helmet, okay? And it's those transition times that actually are very important, and people train to transition. The setup for the transition area is different at different triathlons. Simon participated in the triathlon in both the 2000 and 2008 Olympics. His results for both of the Olympics are shown below. So you can see he completed his first triathlon in 1:48:24 and the second one in 1:48:58. So that's an amazing time. Okay, so looking at this, you can see it was his swim time that probably made the most of the difference. You can see his running time, he was faster here. His cycling time, 2 seconds, but it was his swim time that's about 26 seconds or so, or 24 seconds rather, that really made the difference. Okay, so we can tell by that rate, this is his time. So it was his time for his distance. The distance of his swim was 1.5. So another way that we could look at this is we could graph it, distance versus time. So how long it took him to do a 1.5 versus time. And you can see that the slope of his first one is steeper than the slope of his second one. So this is one way to compare rates. The slope for the 2000 race is about 5.02 kilometers an hour, and then his second race was 4.92 kilometers per hour. And notice that rate came from kilometers per hour. It came from that graph as well. The slope of each line segment on the graph represents his swimming speed for that race. So you can see his speed was much quicker in 2000. So my guess is there was less waves. Maybe he was not around as many people, because that's one thing that slows you down in triathlon is when you're nipping at other people's toes. Can the slopes of the line segments on a graph be used to compare graphs? Yes, the greater the slope, the greater the speed in that line segment. Are the slopes of the line segments on your distance versus time graph unit rate? So unit rate is a rate in which the numerical value of the second term is 1. So instead of saying we do 240 words in 8 minutes, oftentimes we'll say we did 30 words per minute. So notice that whatever the quantity on the bottom, it's per 1 minute. And when we convert to unit rates, that's how we can compare. So yes, the slopes are expressed as the distance versus unit time, which is a unit rate. In our investigation, we use kilometers per hour. So it's a lot easier to say I went 100 kilometers an hour instead of I went 500 kilometers in 5 hours. It's easier for us to understand often unit rates. Can the swimming speeds be calculated directly? Yes. First, the time must be converted to the same unit, such as hours. Then the swimming speed can be compared as unit rates. Okay. Here's another example. Natasha can buy. We're going to compare. So we're going to have different units, and then we're going to compare. And this will happen often in a grocery store, where a box of something will be one price and it's a certain weight, and the bigger box is another price. Most of us just assume that bigger box is a better buy, but using unit rates, we can be certain. So she can buy a 12-kilogram turkey from her local butcher for $42.89. The local supermarket has turkey advertised as $1.49 per pound. There are about 2.2 pounds in a kilogram. Which store is lower? Okay, so let's look at how Dimitri solved this. So what he did is he wanted to put the price per kilogram for the butcher. So he said $42.89 for 12. It's $3.57 per kilogram. Supermarket. So what he had to do is he first had to convert from pounds to kilograms. And you know what? He could have put this kilograms to pounds, but this is the strategy he chose. Either way would work. So he said it's $1.49 per pound, 2.2 pounds per kilograms. And notice this unit analysis, pounds cancel out. If you've done any physics, you should be used to doing unit analysis. So that gives him a price of $3.27 per kilogram. So look at that. The supermarket was cheaper than the butcher. Okay. Here's another example. Describe a scenario that can be represented by this graph. Compare the rates shown and discuss why the rates may have changed. Okay, so looking at this, over 30 minutes, someone traveled 2 kilometers. Then for 10 minutes, they stayed at the same distance, no speed. Then from 40 to 60, so in 20 minutes, they went from 2 to 5. They did 3 kilometers. So this is much faster than that there. Then they came home at an incredible speed. In 5 minutes, they sped home. Oops. In 5 minutes, they sped all the way back to where they started from. So let's think of a scenario here. Let's say I am out for a leisurely bike ride with my friend. I leisurely bike ride 2 kilometers in 30 minutes. Okay? Then an ice cream truck comes by, and Miss Cantillon loves ice cream. So I stop, and it takes me 10 minutes to eat ice cream. I got a really big bowl of ice cream. Then I start thinking about all the calories that I have just consumed, and I say, you know what, I need to pick up the pace, and I bike faster. I bike 3K in a faster amount of time. And then you know what I say? You know what, now's time for my workout. I am going to bike home. In 5 minutes, I am going to bike 5 kilometers home. Wow, I am quite the biker. Okay, so I gave reasons why the rate may change because I suddenly became motivated. And yeah, compare the rates. So this is slow, not moving, faster, and even faster still. Okay. So a couple things to summarize here. Rates can be represented in a variety of ways. The representation you choose should depend on your purpose. You can compare rates by writing them as rates with the same units, with second terms that are the same. So I could have per 2 minutes. If both rates were per 2 minutes, I could compare them. Or more often, we put it to unit rates, where the values of the second term are equal to 1. So both in 1 minute, or in 1 second, or in per hour, or per kilogram. When comparing rates, it's helpful to round values. This enables you to do mental math and express each rate as an approximate unit rate. In a graph that shows the relationship between two quantities, the slope of a line segment represents the average rate of change for those quantities. The slope of a line segment that represents a rate of change is a unit rate.